Hey everyone. In this video, we're going to start applying our geometry nodes knowledge to actually build some transfer setups. In the opening videos on data transfer, we learned about things like the Airgap issue, which we fixed with Shrinkwrap and intermediary objects. So in this video, we'll be looking at examples of how to do all that, but in geometry nodes instead. My topic list is looking a bit sparse this time, but that's because this is mostly a set of examples and demonstrations instead of a lecture about a bunch of topics. So let's take a look at a bunch of different node setups and see exactly what they do for us. I've got 3 big node graphs full of examples set up on the head here, and of course these will be in the file release, so you'll be able to flip through them if you aren't already tired of looking at all of these crazy nodes from the video itself. Let's take a quick preview. I'm recording this intro after, of course, so we're doing crazy things like this is snapping the face to our source object, which is this test sphere, and then this time we're raycasting to it, so that's much better. And what did I even have here? Yes, this is the sphere raycast to the face, and oh yeah, visualizing raycasts, tons of cool stuff. Man, it was only like yesterday I recorded this, and I've already forgotten. That's funny. If you're wondering why we're going to all this trouble, this second example shows it very cleanly. So here's a nice normal transfer where we've used intermediary objects that have closed the air gap, and if we disable this, that's what our transfer looks like without it. Terrible. We've got all sorts of problems. So make sure you keep watching so that you don't end up like this with your normal transfer. And in the third big example graph, we are taking a UV map transferred from here, and we are unwrapping the face and flattening it into a UV mesh, and then looking at ways we can improve the quality of that transfer. This is the high quality version. You may recall from the series overview video that these flat unwraps are one of the most important parts of the setup. So we're doing all of this so that we can get this with as little distortion as possible, and once we have it, we do all our transfers through this with no distortion. But we have to get it in the first place. So that's what this video is about, and then in the next video, we'll actually use it to put together our actual normal canvas setup, which we'll use for details and layering and baking and all that. But for now, enjoy transferring UVs and position. Okay, so we've got our usual test head, we've got this nice face mask, which can be used for either normals or UVs, and we're going to want to transfer stuff from it to the face. And as we've learned in previous videos, we need to solve the air gap issue if we really want a nice transfer. Previously, we solved the problem with like shrink wrapping it to the face or the face to it, or we made shape keys and we did all this stuff. And it's basically the same idea in geometry nodes, but we can do it all in the node tree and not have to have a bunch of duplicated objects, like literally duplicated objects. We'll just duplicate geometries in the node tree. So are we going to have to go off on a whole rabbit hole about how to do shrink wrapping in geometry nodes? Well, we don't, because we already learned it. And that's because everything we've been learning about transferring normals also applies to transferring anything else. And in this case, position especially is very similar because it's also just a vector, but representing position instead of rotation. So all we have to do if we wanted to, say, transfer some positions is, well, this thing we've been staring at, so I'll just turn it on. We've transferred the face to the position of the mask. And it looks pretty ridiculous because it did the entire back of the head too. So yeah, nothing complicated. We've got the face mask object input here, and so that's coming in there. So we're getting the position of the face mask. We are transferring it with nearest face interpolated to our head geometry, setting the position, and that's that. If we like subsurf this, it'll look a little nicer because, you know, snapping to a low poly shape isn't going to be that good. And this is basically identical to some of the options on the Shrinkwrap modifier. Now there's a lot of options on it. This isn't quite the same as all of them, but it'll serve our purposes. And just a note, here I've made a geometry node subsurf, which is just geometry node subsurf, and this way I can have a choice between this and regular subsurf because I'm using like simplify to control regular subsurf. So so that's why I have that. Now let's fix that back of the head. I have a vertex group that I'm inputting here to mask just to the front of the face. So that's working pretty well. It looks a bit funky on the eyes because those have some depth where it's, overlapping. So it's not really doing anything wrong. But what are we actually accomplishing with this? So we're doing this setup so that we don't have any distortion from the air gap. But this is a proximity nearest face interpolated transfer, and we have an air gap when we do it. So even if we now do every other transfer like this with the meshes lined up, or what we'll do in the long run is flatten them to their UV maps. We'll transfer UVs like this and then flatten them to their UV maps. But any transfer we make based off of this is going to have the air gap we've already got baked in. So basically, we've got some amount of distortion from the current air gap transfer, and the question is that an acceptable amount, or do we need to do more things to reduce it? And that could be a different setup, maybe projection instead of nearest, or it could mean making some manual adjustments to this. If we're going to transfer the UV map, maybe we'll transfer it, apply it, and then hand correct the map. And what we need to do depends on how much distortion we've got on any given meshes. There's not necessarily going to be one setup that will work for every single mesh. So what we're going to do is look at a bunch of different ways of transferring position, and we're going to use a material that lets us see how much distortion we're getting quite clearly, and then we'll understand what does what, and for every given pair of meshes you might need to transfer between, then you can make an informed decision. We're going to troubleshoot any distortion we might have by using the UV map transferred from the face mask. The face mask itself has very clean UVs. If we render, we can see there's our X and Y, and that is X for horizontal and Y for vertical. And these are being mirrored, by the way. If I uncheck that, then it's 1 to 0.5 in both directions because it hasn't been mirrored. So we do need that on the mirror modifier. If you're not using mirror modifier, then that's a whole other issue. We'll talk about making this face mask and getting these UVs in the first place later. So UVs are good for this because it's easy to get a very clean display of something like this. There's our UV map. And this is essentially a grid texture. We can see the slight unevenness, and we can see some wiggliness. And that's because our mesh is pretty low poly. If we subsurf it, then that pretty much goes away. And with 2 levels of subsurf, it's gone. This group I'm using for this is similar to using a wave texture, but it's a bit fancier because I have it set up to allow us to see a bunch of different things. I use this for viewing and troubleshooting UVs in all sorts of situations. And here's the inside of the group if you want it. It's using modulo to make the grid based on even increments. And I'll put this in the file release. So this grid is at even increments in UV space. We can see, though, that it doesn't quite correspond to the loops of the topology, and that's because the UV map position of those loops has these offsets. If I start moving things around in the UV map, you can see that, you can line them up and position this however you want. Back over on our head, the UVs are totally scrambled because right now the UV map is just a smart UV project. So it's a total mess, that one. And so it looks completely crazy because we're just drawing lines across all those mismatched islands. So now let's try transferring the UVs over. We could use a data transfer modifier to transfer the UVs, but we're going to want them in our geonodes anyway, so let's just look at how to do it there. So on the model, we have a UV map, and it isn't under attributes, but it is an attribute. So like here for the UV, I was able to select UV face, which is our UV map. And it shows up properly. And in our shaders, we have a UV map node, or if we type the name, we can get the exact same thing from the attribute node. But here's where it gets a bit odd. When I turn on the transfer, well, we're getting black now, and that's because we have a UV map output, and it's outputting to UV face, and there's nothing going into it right now, so it's just black. We can chuck a color into it. Grab color and put that in UV, and now we'll see whatever we plug in, because it's a generic attribute, just like we learned with normals. So when we look at the attribute node, we have that. When we go back to the UV map node, though, it is black. So I don't understand how this all works exactly, but basically, once you are using a geometry node's output to the UV map, then you have to use the attribute node. The actual UV map node does not work anymore. So just keep that in mind. So let's look at that. Let's do our actual transfer here. We've got the object info node. We're bringing in the face mask here with the input. We've got a transfer attribute. Unlike normals, we don't need to worry about capturing the UVs as point or anything because they're already face corners. So we transfer that, and there we go, transferred UVs. And if we take a look here at the grid, it looks pretty good, actually. It's a bit weird on the back of the head for the usual proximity issues, but we're just going to keep ignoring that. So it's nice and clean. It's a bit weird in some places, like the eye sockets, because of those being inset. So you can see it gets wiggly there. If we turn off the subsurf, things look a bit worse. So it's a bit hard to gauge, like, is this area correct when it's also kind of wiggly over here? Well, it's not here, so that is getting some distortion, it looks like. But that's also going diagonally across faces. So it could be that the distortion from one area to another, from mesh to mesh, is not distorted, but then this is getting distorted by interpolation before it gets into the shader. So we have to keep in mind when trying to judge if this is distorted or not, that there's lots of things that can distort it that come in at different points in the pipeline between the mesh and our shader. And some of them we should worry about and some of them we should ignore. And of course, turning up subsurf is fixing a bunch of that. And if instead I'm going to turn on subsurf with the regular modifier and everything, with one level of subsurf on each, then basically all of these wiggly problems just disappear. So that tells us that they are not transfer distortion, they are interpolation distortion. Where we can see transfer distortion, though, is like the tip of the nose here. Look at how that line gets fatter there. And the way we can really tell is if I use my shape key that flattens the nose, now it disappears. So that distortion is being caused because the nose is sticking so far outside the mesh that it's kind of messing up, like, what's the nearest point of this? We've seen issues with the nose and projection in the past. This isn't quite the same, it's just a nearest issue. Similar things, if we look at the eye sockets, so if I flatten those a bit, then they make more sense. They're still a bit wiggly because the shapes are kind of off, because that shape key I'm using just isn't very good. But neither of these issues are particularly large. You can also spot the distortion just looking at what happens to these lines as they hit the real face mesh. So it's going mostly straight, then it hits here, and it's going off at an angle. And like here you have a break, and there a little bit of one too. So you can see that there's some distortion, there's some offset happening. So does this amount of distortion actually matter, or can we just use this? Well, distortion matters if you're going to be using the UVs with an undistorted input. And by that I mean, if you have like a procedural texture, like what we're using, and you don't want it to be distorted, then the UVs have to be clean. Or if you're using like decal textures. But if you're using the UV map for baking or for painting, then the UV distortion doesn't really matter because it's just going to be baked into the texture. So in this case, we do care about distortion a lot, even amounts this small, because we will be using it like the first style. The solution to these small problems for this particular model is the shape keys I've been showing. And this mask was basically optimized for this face to get a clean transfer. And this is good enough to use. It's not too great in the eyes. I should probably hit that with the smooth brush a bit more. In the eye socket itself doesn't matter because that'll be covered by the eye, but like over here it could matter. So we'll get back to that. But first we're going to look at some other examples with a transfer mesh that isn't already optimized. So here we have a sphere, and it's got a UV map. Its UV map, it starts actually at the back and it wraps around, so the spacing is a bit different, but we can still see the distortion stuff. And I have squished it to fit around the head, kind of like some of our earlier normal transfer objects. And we're going to take a look at what sort of transfer distortions we're getting from this. So let's try a transfer. We'll plug that in there. Its UV map is named the same thing, so we can just do that. And, oh dear. So this is the kind of distortion we really don't want to have. And we can try a subsurf on it. Doesn't really help that much. We've got a subsurf on the head already, and it's still this bad. And that's because we just have such a giant air gap. So let's see if we can close it by transferring position. I've grabbed a transfer attribute node. We'll get the position of the sphere, and we will transfer it to our geometry. It's going to get a bit noodly here. So geometry goes, goes in there. And we'll plug that in. And now this is similar to our old cast modifier trick. So our face has been projected, well, projected in proximity, not with rays. It's on the surface of the sphere, and now when we do the transfer, it's actually pretty good. In fact, it's perfectly clean. But we don't want the head to be in the shape of a sphere, so it doesn't do us a lot of good. We do want to keep the original position. So we'll transfer this back from the transformed head back to the original version. We can use a index transfer, and now it's the right shape, and that just looks the same as when we started, right? Let's double check that. So there's our transfer that has gone through the position change. Make that 1, and then let's get a transfer that's just the attribute with a regular position transfer without all that. And if we mix between them, it's exactly the same. What? But if you stop and think about it for a moment, of course it would be the same. This version, where we just do a proximity transfer, is getting the nearest point and giving it the UV map. Whereas in this version, we also got the nearest point, we set position to the nearest, and then we got the UV map, and then we set it back. So in both cases, the nearest point is the same. It's just with one we moved geometry around and with the other we didn't. But it didn't change what the nearest point was, so it's the same result in the end. What will be different is if instead we do a raycast setup. So here we've got our raycast absolute node from the last video. We're using the sphere as the target, and let's raycast and set with the hit position. And we can see right now the direction is -1y. Well, it's both directions on y, so that looks pretty funny. But we'll change it to the normals, and now it's raycasting out to match the sphere on its normals. And that looks pretty crazy, so this probably isn't going to be a functional result, but let's see what it's actually like. Again, transferring it back to the original mesh, and it's not right, but notice that it's wrong in a different way, and it's not as dirty. So that is definitely different than what we had before with the proximity, but it's still not ideal. But we could try another setup. Why don't we try raycasting in a more useful direction? Raycasting from the normals isn't going to necessarily give us any useful result, as we've learned using projection before, because these faces are pointing every which way. It's not going to give us a consistent mapping to the sphere. So if we just raycast on the y-axis, then that actually gives us a very accurate mapping on y, but it is kind of flat. So, that can actually be useful sometimes. It's no good on the sides. But if you were only trying to cast like the very front section of something, then this actually works fine. So let's try something totally different. The math here, what this is going to give us is a ray that goes from 0, the origin point, through each vertex. And that's actually pretty interesting. That looks pretty nice. And that's because this is giving us, it's got nothing to do with the face orientation. It's just a ray through each vertex that will then hit the sphere. And since that's going to be a fairly spherical projection hitting a sphere, it's going to give us a fairly even result. Now, what I just said may be difficult to visualize, so I have brought back our visualization group, and it's still kind of hard to see, so I'll turn off mirror so we can view a cross-section. And now we can see what our rays are doing, especially if I do that. So we're getting the difference between 0 and the position of each vertex. So it's the angle from 0 to each vertex. The rays going in that direction and then continuing on, and we can see where on the sphere it's hitting. And why not make it even crazier? I've now made it, instead of 0, it's the location of an empty object. So now the ray casts from the empty through each point, and this is a bit laggy, but you can see that's determining the angle to cast the rays at, and that's determining where it's going to hit the sphere. And that's going to determine the distortion of the UV map. I've turned the visualization off so we can just see what this is doing. So this is what it's actually doing to the texture. And that's not because it's warping the UVs, it's because it's changing the raycast. It's always the same UVs. We're just changing where on the sphere it's getting the information from. So you can make all sorts of crazy setups like this, and you can even animate them and stuff. This is similar to things you could already do with some of the UV warp modifiers, and this projection is similar to stuff you may have dealt with normal edit before. So that's cool, but let's move on to the next thing, which is instead of casting from the head to the sphere, what if we cast from the sphere to the head? So we're doing that here. We've got the target being the head, and it's being cast from the sphere here, and we'll set position. The sphere has now been wrapped onto the head. And I use this less than here, because if you don't have this, we turn that off, then stuff down here goes all the way back up to the front of the head, and it's a mess. So that's why this is here. I think we can do that with ray length too. Let's try that. Yeah, ray length is going to achieve pretty much the same thing. And although it's just setting to 0 in that case, but it doesn't matter. This is a bit more elegant, so I haven't set the full mix. Whatever, don't worry about that. So what does this look like if we do this and that? That's actually pretty nice too. And the reason this one is nice is because we are using normal direction again, but it's the sphere's normals, and the sphere is nice and even. So it's going in from each face, hitting the head, and then snapping to that, and then it's actually a proximity transfer once we've aligned the two. So that works pretty well for actually closing our air gap and reducing the distortion. We still have some bits here that are weird, but just compare how clean most of this is to what we've looked at so far. And if we do our usual thing with the shape keys here, then actually that's pretty much solved most of our problems. There's a little bit of wiggliness there, but you can see how big of a difference this makes. And this is a fairly simple node setup, and you can just set this up and leave it here and then do whatever else you want. So that's a big improvement, but it's still not going to be perfect just because at the end of the day, this isn't a great shape. But we will test in a minute if this is now good enough to transfer normals cleanly. But first, let's look at some other examples, because I'm sneaking in this lesson on transferring position and snapping things to each other. I made all of these. So we had the proximity of face to sphere, and we had the raycast of face to sphere, which looks pretty good. And we've got the raycast of the sphere to the face, which also looked good. And down here, we've got the crazy visualization of the face to the sphere. And down here, we're back to our mask. So this is the face to the mask, and this has a problem that we should talk about, which is that if we look at that center line, it is messed up. And that will go away if we turn on the subsurf. It's still not perfect, though. So there can be issues with center lines on mirrored models. And that's because when it does the transfer and it's trying to get to the center, it doesn't exactly know where to go. So it can land on the wrong side. So I've made a node group to fix that because it can come up in all sorts of circumstances, so you might as well know about it. Make room for that. Drop it on there and plug the original position in there, and centerline is fixed. So what is this doing exactly? We're getting the new position that we need to correct, and we're getting the original position that we are masking with. And it's a pretty simple group. We're only affecting the x-axis because we're correcting x-mirrors. You can make a version of this for other axes. And this is basically the logic. So of the original position, which I'm calling mask because we're masking with it, it checks if the x position is equal to this input, which is 0 in this case, and it's got a bit of an epsilon to check around, which is actually a very low number here. It's not actually 0, but if you don't have a bit of an epsilon, then it can miss things because of floating point errors. And if those are equal, if the original position was equal to whatever we put in here, which is 0 in this case, then it returns true and it sets the x position of those points to be 0. Let me phrase that another way because that was a mouthful. What this group is accomplishing is if the vertices were on 0x before, then they'll be set to be on 0x in the new position as well. But we can define what the point they needed to be before was. So right now, this head is located with the middle of it is at 0. But if this was some geometry that was over here or something, then we might need to say the middle line is minus 0.1 or something. So maybe I should rename this to middle line, but this is basically what you're detecting is the middle line, and this is what you're setting it to be in the new position. Okay, yeah, I've changed those input names, so that should make a little bit more sense. So I'll put that in the file release as well, and I'll leave this mess if you want to look at these. But for now, let's move on and see about actually transferring some normals with what we've learned. Here is our practical example. We'll look at the setup first with UVs. It's a combination of things we've already looked at. So we get our sphere. We raycast it based on its normals to the head. We get our head. We raycast it based on its position onto the sphere that has already been raycasted to the head. And that looks really funky. It's freaky because of the eyes, but they're not really wrong, they're just weird. But the nose is wrong. Look at that. Like, what is going on there? If we look at this mesh, it looks fine. But if we look very closely, we can see that the issue is actually triangulation. The mesh is being automatically triangulated, and it's not symmetrical. So we will take control of that triangulation, like this. And now the triangulation is symmetrical. And now this is also symmetrical as it should be, but still freaky, but whatever. If we enable subsurf on the sphere, it does improve. Then it's still freaky, but it's smooth at least, because a bunch of these issues are to do with it just being too low poly here. So we'll leave that on. And if we render, we are currently transferring to this head with nearest, now that we've synced up the positions. And then we're going to do one more transfer. The first transfer was nearest. Now we're going to do index back to the original mesh. And it looks pretty good. I'm not entirely thrilled with the nose there, but we know the fix to that would be to turn on the shape keys. There you go. But even without them, that's working pretty well. And like, that line being inset in the eye socket isn't really incorrect either. It's just, it's not what we'd expect visually or artistically, but it's not wrong based on how this little program we've made actually works. And now we can enable and disable different parts of this and see what each step here actually contributes. So let's turn off that freaky step, and we can see it was actually making quite a bit of a difference. It looked weird, but it's really helping around the eyes and on the nose. If we had the shape keys on, we don't really need it. But without them, it's a decent substitute for them. And if we turned off the original here, we can see that's not really a matter of how clean it is. Well, now it is. On its own, if we just had the face to the sphere, then it's still pretty clean, but it's kind of in the wrong place. The grid is too uneven. So basically, the sphere to the head is making things properly even, and then the head to the sphere is making them clean. You can think of it that way. And if we leave the triangulation off and this off, it's kind of funky. Although the triangulation isn't really making any difference either way over here. It looks weird, but again, what matters is that it lines up cleanly. It doesn't actually matter if asymmetry gets introduced as long as they're both asymmetric in the same way. So that's the UV check. Now let's come down here to where I've set it up with normals. And what I've done here is I'm using a group that I've made that will also be in the file and that everyone will probably want. This group is for making it so we don't have to make a million nodes every time we want to transfer normals. It gets our normals, it's capturing them as point, and then it has 3 different transfer nodes that are commonly used: nearest faces, index on face corners, and index on point. And then the idea with this is to just use whatever output is appropriate to what you're doing. So instead of having to duplicate all that stuff over and over, you just use this. Now this may look busy, but a bunch of this is just these things we talked about last video where we check to see if there's anything plugged into this input. So in this case, the source position field has a default value of 999 in each field, 9999. And so if it's been changed from that, then it will use what's in the input. And if it hasn't been changed, it will use the original position. So this would get weird if you happen to be trying to use an input where a vertex was at that, because it's checking this per vertex in the mesh. So that could get weird. And in that case, you need to change what this is. Now down here, for this one, this is for indices, and indices can never be -1, but I've set this field to default to -1 and to check for that. So this will never mess up because nothing you put in as indices that would be valid indices would ever be negative because they're always a positive integer. So that's that group. And speaking of groups and updates, I've also added something into our attribute to normals group, which is the same check for a default value. So what this does is that if nothing is being inputted, if everything is just pure black coming from this input, which would mean that we had no attribute normals plugged in, then it will use the other socket of this mix node, which will normally be the actual normals of the mesh. But at the moment, I've set it to just be this teal color for debugging purposes. So the point of this is just, if there's no normals, then it's just going to display teal. The same way, like, if a texture is broken, it will display bright pink. And we could see that, like, on here, now the head is plugged in, but I didn't plug anything to the normal output. So this is just a visual reminder of that. And if it had the normals plugged in, then we get the base mesh normals. So that's what's going on there. So we capture the normals from the sphere before we set its position. And this is another thing to know about. Let's get our output here. So when we capture the normals here, there's our normals. And then when we change its position, because they were already captured, it's keeping the normals from when the mesh was in this state as opposed to normals when the mesh was in this state. Whereas if we got the normals again from a node, they're flat right now, so I guess we'll just duplicate that. If we capture them again after the change, then of course that's going to affect the normals like that, which, is junk. We don't want that. So you can get normals from a previous state of the mesh, well, from the proper state by capturing them before you make changes. Or if you don't want to do that, you do a index transfer from one state of the mesh to the other. So we could have, well, if something had changed to the mesh or if this was a copy, then we could be using our corner index field to get the same thing. All right, so we capture the normals earlier, then we set the position, we do the triangulate, that doesn't actually mess up the normals. Then it does make things pretty weird at the ears, but who cares? We don't care about the ears. Then we go ahead and change this position. Technically, we can preview this transfer here. It's working, but again, this one is weird because of the eye area. But the final one that matters is this one, and that is working beautifully. So this transfer has worked quite nicely, but how much has it really done for us? Like, did we need all of this? And I could disable these, but the easiest way to see is to compare the two. So we'll do a mix between this and this output. This is just a nearest transfer between the original sphere, and this is how much it is doing for us. And we can see that that is pretty nasty. And this way, it is very nice and clean. Move that around a bit, really get an idea of what we're dealing with, like, oof. So this is the difference between having the air gap closed and not closed by this particular setup. And if we turn off subsurf, of course, then it's going to be even worse. I wonder if we have subsurf on both of them. Let's try that. Yeah, more subsurf on the face does not help with this. So this is why you gotta close the air gap. And let's turn one thing off at a time. Here's the face to the sphere. So as we expected, that's not really affecting how clean it is too much, but it is affecting the shape a little bit. But if we do this part, also not too bad. It's changed the shape, but it's still pretty clean. And if we do everything, then it's screwed. And just to triangulate, I don't think makes a huge difference. It would be very minor what we'd notice. So it is, the magic is from having all of it. It's not just one or the other. So this example has demonstrated why we really need to close the air gap to have clean normals. We noticed that the air gap kind of messed up our UVs before, but it wasn't shading we were looking at, so it wasn't as, I guess, obvious and literal of why this is a problem. Like, you could get away with having some jaggedness in your UVs, and as I said before, depending on what you're doing with them, it may not matter. But for normals, it's gotta be clean, otherwise, why bother? And the UV transfer is simpler because changing the source mesh doesn't change the UVs. So we don't need a middleman, so to speak, although it may be convenient. But with normals, you have to have the original state of the mesh that creates the right shape, and that could be totally wrong for having a clean transfer. So we have to do this extra step. Now, of course, from the first video, we know that the best intermediary mesh to transfer through is one that's been unwrapped and flattened, which we do with UVs. But I didn't go straight to that because I wanted to show you setups for a situation where you don't have a clean UV unwrap. You know, if you're not doing something much more complex than what this sphere or basic face mask will give you, then you don't need to necessarily worry about UVs. But for details and layering different normal sources and all that, we are going to want a flat UV canvas to transfer through. So that's what we're going to look at next. I've made another modifier, and I'm leaving the previous normal transfer and position transfer examples as their own modifiers here for the file release. So we're on a new copy, and we're inputting the face mask again. So luckily for all of our sanity, this UV flattening thing is something we basically know how to do already, we just didn't necessarily realize it. So here we've got a very simple UV transfer setup without any corrections. And all we're going to do is take our main mesh and set its position to be the UV map. And it's gone because it's actually over here. And boy, that looks crazy. But there's the head flattened to the UV map. So what are we even looking at here? Well, this is the transferred UV map. We can see that here is 0 and here is 1. And the reason it's laid down flat like this is because UV coordinates are X and Y only. So we're using the UV coordinates as world space position coordinates, which is actually perfectly compatible. We do have some weirdness though, and it's going to take a little bit of cleanup to make this usable. To make this a bit easier to understand, I have applied the transferred UV map, which I've done off screen because to apply a GeoNode setup, well, you can't if you have shape keys, so you have to delete the shape keys and then apply it and then transfer the shape keys back from a copy of the mesh and all that, and yeah. Anyway, so we have that UV map on the mesh. We can just look at it directly now, and we can see it's the same one. And if you don't have the transfer, you can just do the whole UV right here. So with that applied, we can flip to UV editing mode and see what's really going on here. If we select everything, well, we certainly have a mess. So part of it is mirror modifier. Let's turn that off. And then most of it is just the back of the head being snapped to the front again. So I've got a vertex group of the front, and I'll invert that and hide everything. And now we can see what we actually want to work with. But it's not aligned in the center, and it's not aligned at all the edges. So there are still some issues to deal with, but basically we're getting kind of the right thing, but there's a bunch of distortion. So let's go through and solve each of these problems. I've got a bunch of progressively fancier setups here again. So first of all, the other problem we have here is if we plug that in, then we're setting it to the position. This is transferred to here and then set, and now this is being transferred to here, so it's a total mess. So to solve that and to solve some other problems, let's grab this setup. And it looks very nice because now we're capturing the UV map and we're fixing the center line. So now we get a better example of using our fixed position center line group. So again, we are getting the original position of the mesh. The position of the mesh in this state before it's been flattened. We're checking what is at the center line of 0. And then in the new position, we're making sure that all of those points get snapped to a center line of 0.5 because the UV map is from 0 to 1, so the center line is 0.5. So that has fixed our center issues. And then because we captured this and transferred it after, we have a perfectly clean UV grid. So previously, when looking at our UV maps, we were looking at the map transferred onto the face geometry. The face geometry was unchanged, and we'd be looking at distortion in the UV grid. Now we're looking at the same mesh, but transferred to UV space, so the grid is always perfect, but we can see that the mesh might be distorted, like around the eyes here. And so this is another way we can view what's going on and troubleshoot our transfer. It's a bit hard to look at because we still have the back of the head snapped in here, so let's come to our next setup, which is the previous setup, but a little bit more to resolve that. So now we're no longer changing the position of the back of the head. We're using our mask vertex group, and we're only snapping the stuff we want to. And we're solving problems by splitting the edges. If we don't split the edges, then there's still faces between the original position and the flat. And when you're working with a regular UV map, it is splitting everything on the seams anyway, but our setup isn't doing that automatically. You may remember in the previous videos, we made a setup where we could split edges based on a vertex group. But in this case, because we're working with face corners for our UVs, we can get away with just splitting the entire mesh. So yeah, we'll just do that. And then we'll transfer with face corners again back to the original mesh in the end. And we've got this capture attribute here, which is doing something quite important. I'm going to plug this in here and set the material just to display that output. So our vertex group mask, when it comes in, it starts off like this, because it is point data, because it's a vertex group. So it's got full strength on these vertices, and then a gradient down to 0 because it has no strength on these. But what we want is to have full strength on this whole face, because we're using this to set position based on face corners. We want to move this face corner, but not this one, and if we do it on this point, then it'll move both, etc. Or, well, if we don't have this, then we still have those faces getting some amount of the transfer. So this is an important part. And to understand what it's actually doing, when you capture onto the face, if any vertexes in the face, any of the vertices in the face have any value, it gives you the whole face. And you can actually do a selection erosion by switching back and forth. Check this out. So let's change this one to point, and then we'll drop the face over here. And now we've stepped the mask in by one. So I guess this is totally off topic, but you can use different captures to adjust what area of the mask you're using. Anyway, back to the proper setup. So there's our UV mesh. We need to do something with the rest of the head at some point, but for now, we're going to ignore it because we're more interested in looking at our distortion amount, which is a bunch around the eyes here. Like, what is that? But then it's not too bad in the rest of the face. So what's influencing this? Well, part of the reason it's not too bad is because I have my transfer position shape keys on. If I turn those off, things get significantly worse. And between these videos, I did actually go and improve these a bit too. I made the flattened eye one a bit better. So now those loops aren't getting as screwed up, because before these loops were coming in a lot. So I did actually change that. So as I turn these on and off, you can see how much of a difference they're really making. Like the eyes, they're still distorted, but they were way worse. The nose with the flatten is pretty good. Without it, you can see it's really getting pinched in. And if we put the real head next to this and compare, then visually it's easy to tell how much distortion we have. And at the edges, we can see for the ears that it is helping the ears go all the way to the edge. And it's easy to see why if we look at the actual meshes on top of each other. Like, without the ears being flattened, then it's just going to completely change what is closest to what. And same with the nose. Again, the nose not sticking out of the mesh is just making a huge difference to the accuracy of it. And of course, the eye distortion comes from the area where there's still the largest air gap, because this transfer mask is not inset like the eyes. So everything is basically what we'd expect it to be. This just is what it actually looks like in practice. So let's improve it. The easiest lowest hanging fruit is just to get our subsurf going here again. That smooths everything out across the whole mesh. And especially around the eyes, it's making a significant difference. But some things get better and some things get worse. Like, these loops are about right, but when I subsurf, now they're worse. But then these are a bit better. So it's definitely changing things. I think it's improving the center line too. But it's not going to solve our problem. And like, more levels of it don't really help much. And if we turn on subsurf on everything, including the head, again, things are better in some ways. They're more evenly distributed, but it's not really solving the main areas of distortion because those are just from the big air gap. So the problem is air gaps, and that's what we've been learning about all video. So let's try some of those. I've got a Raycast set up here. This is the one where we have cast the face's position onto the mask, snap the face to the mask. And we have the same transfer with the center line fixed down here. And when we plug all of that in, hey, that's a lot better. And it's pretty easy to see the difference, because we can just toggle this on and off and see how the Raycast is affecting it. So this is consistent with what we learned before, that using the Raycast does definitely help with some of those air gaps. It's helping around the eyes a lot. Now, I'm not sure it's improving all of the face in the same way. It probably is, but we want to go and check, and we may in the end use some mix. We might use nearest in some places and Raycast for others, because in the places that don't really have an air gap, nearest should be just fine. And as before, if we turn subsurf on the UV source mesh, then it cleans up a bit, and this time it's not creating new problems. Everything looks pretty good to me, actually. A little bit of spacing up there, maybe. We could do further inspection, but since this is just an example, we're not going to put in the time. We'll save that for the final setup. And that final setup will be the subject of the next video. In this video, we've mostly covered, hypotheticals of generally how do these tools work, but now we're going to go and actually make the setup that we'll use for this head so that we can move on to detailing and layering. So thank you everybody for watching. As always, feel free to leave questions in the comments, or you can contact me at the social media accounts or email on the YouTube About page. If you're trying to do these things and getting stuck, I will help you. And of course, like and subscribe, and don't forget that if you like this content, you can support me on Patreon. Thanks, and I'll see you next video.